Today I would like to show you a live presentation of reloading a mainframe application that just a few days ago was running, and well, is technically still running, on a legacy mainframe. We unloaded and packaged this, and we are going to reload this today onto an Azure environment, fully automatic, binary compatible, with its data and everything exactly the same like it was before. And I have been given around roughly, well, now it's a bit more, fortunately for me, because he finished early, so I have maybe 45 minutes to do that. This has not been done before, and certainly not in a time frame like this. Migrating a Kix DB2 mainframe COBOL transactional application onto Linux, onto the software defined mainframe on Red Hat. So good luck to me. The first thing that I would like to show you would be the Azure portal. Since a few weeks we've been fiddling with Azure, and Azure being a really sophisticated cloud offering here enables us with the functionality to fully automatically deploy formations of environments if we want to. This can be achieved using templates. This is also what I'm going to be using here now. If I maneuver to templates, we have here our Gotthard release, which will, by the way, be also available in Azure to purchase from us. So if you want to try out the software-defined mainframe, you can just, we give you a subscription key, and you can use this template and deploy your own software-defined mainframe if you wish to test your applications. And migrate it relatively easy. So we have this template here. This is called a solution template. And what happens when I deploy this is it will create a new system, because currently, and maybe we do that first, just to see that I'm not actually doing something. So first, I have these systems. Let's see, is it loading? Yeah. These are the systems defined. So what I need is, I need a fresh new environment to port my application. So I don't have a system yet. So I'm basically starting from nothing. I just have a template and I have a package, which I would like to show you afterwards. So the first thing I'll do is I create myself a new environment to run the software-defined mainframe. In this case, it will create me a single instance with the network, the storage associated to run. This could be scaled up or sideways, better to say, where you could cluster it, load balance it. You can create multiple systems. You could even create scenarios where these things happen fully automatic, where just imagine an environment if you need more throughput. You want to scale up, you say, okay, you don't have enough performance, you just need more systems, more database, more space, and the system just automatically deploys the system and recognizes it in an automatic way. These things are possible in highly automated environments. I particularly like highly available and automated environments because from an engineering perspective, those are really attractive, because engineers, traditionally, they are very lazy, and I don't have to move like this. I can control the whole infrastructure from just sitting in front of my desk. It's really nice. So let's create this system now and deploy a new environment. So I clicked on my template here, as you can see, and I'm going to just click the deploy button. So I have to parameterize certain things. These are just standard ones. I have to, for example, I have to give the environment a name. Let's just call it Liberator. Okay. So here I can select how much power I want for this environment. I'm going to select the NUC equivalent version in the cloud. In this case, it would be a DS14. It's a rather powerful instance. Azure has a lot of powerful offerings. Even though the cloud is about scaling sideways, Azure offers a lot of possibility to scale upwards as well. You have a lot of power. I mean, we're talking like very heavy systems you can do. So even if you want, or your application can only perform in a monolithic environment, it will still function just fine. So I'm going to set here a password. Has to be complicated. So, okay. So I select OK. Do I want to save? I don't know, maybe. Okay. So I have to select that I want to deploy this in my environment here, which I do. Obviously, I have to review the legal terms. Are you really sure? Did you read this? Maybe yes, sometimes. Do we? So, yes, I agree. Do I know what? Maybe. So, going to pin to start, and I'm going to create my environment. So, it says deployment started. This will take a minute or two. So while this is ongoing, in Azure it's doing its thing, working as designed. What I will be doing now is I would like to show you the application and the unload of said application from the legacy mainframe. So let me show you this video. I'm just going to prepare it here quick. There we go. Where is it? Here. Ready? Good.
Hello. So we're here at a mainframe site, and today we're going to migrate an application that accesses a relational database management system from this mainframe to one of these. Hello. So here's an online transaction that's running on the mainframe transaction server. The transaction is called IC08, and it will manage country codes stored in a relational database management system. So first, let's insert a new country code. We're going to enter LZ for LzLabs. Now we can display the country code. Okay, so this is a very simple application. This just gives you an idea of what we're going to migrate. So you can see that application running on the LzLabs Software Defined Mainframe. Okay, so as you can see...
Okay, maybe go back quickly just to see. Maybe some people of you recognize this screen here. This is a TN3270 screen. It's a very old Telnet version that was created specifically for this environment. It represents old school. This is legacy. This is a legacy application. This application here, in this case, it's actually an assembler map for a TN3270 application, as some of you might know. This is a KICS application that accesses DB2 tables, right? So maybe you want to remember how it looks like, just in the end when we are comparing, so we know what it looks like. Okay.
Okay, so this is a very simple application. This just gives you an idea of what we're going to migrate. So you can see that application running on the LzLabs Software Defined Mainframe. Okay, so as you can see, we've started the Data Migration Assistant tool. We're going to select option 1 so we can identify online transaction processing regions. We'll select our KICS region. And we're going to select option 2 to identify our resource definitions. We will pick our group list that we're going to migrate. And we'll select option 2 to migrate the list. This list contains all the resource definitions for our online transaction processing application. We're going to back out now, and we'll select our relational database resources. Okay, so let's select option 2 to identify our relational database management resources. We'll select our subsystem, and then we'll select databases. We'll select our database, and then we're going to migrate all the tables in that database. Now we've generated the migration unload job, we're going to select the action bar RDB, and we're going to execute that unload. Okay, great. So now that that's running, we'll back out and we're going to import our user DDL. This is option 6. And we're going to select an M to migrate that user DDL. Okay. So now we'll back out and we'll select our core files. And we'll select the application load library. Okay, great. So now we've got all the files we need in our migration list. We can now generate the migration unload JCL. We'll go up to migrate, and we'll select option 3 to generate the migration JCL. Excellent. So now that's been generated, we can run the migration unload. This will generate the migration package. Once the migration unload is finished, we can generate the transfer JCL. now that's done, we can do the transfer. Excellent. So we've now successfully migrated an online application to the LzLabs Software Defined Mainframe.
Okay, just to quickly recap what happened here. As you can see, the process of unloading, even with our simplified data migration assistant application here in ISPF, you can see that extracting these resources, because especially they are so entangled into the system, is not relatively easy. So especially here, just to see and explain what we actually unloaded here. We have KICS definitions, we have DB2 tables, we have catalog definitions, we have the definitions to create the tables and the indexes, we have load libraries and all sorts of things. One could add additional things like security or IMS databases here as well. So yeah. So what we created here, let me just quickly, it creates a string. So what you can see here is that this file that we unloaded or packaged from the mainframe, we generated a unique Md5 hash. Some of you might be familiar with this. An Md5 hash is a unique identifier for a file. In this case, the package that we unloaded. Just to make sure, and I want to guarantee you that this is real. Even though we asynchronously unloaded this application just days ago, we are using the same file. This file that has been generated here is the same file that I'm going to reload now in the system that should have been deployed in Azure. So maybe you want to remember some of the digits here. I know I could just say something. For example, just remember the last 3 digits, 3DD1, for example. And I'm going to show you the file that I have here on my notebook. So as you can see here, this is the same file that we unloaded from the host. Okay, so before we upload this and reload this and execute this application, what I would like to show you, or would like to verify first, if the system has been deployed. It should have been finished by now, so let's quickly go back to Azure. This is again the Azure portal where I can manage my infrastructure. It says deployment succeeded, which is nice. So I have a new system now. The thing is, I don't know where to connect because it has been automatically assigned parameters, especially IP address. So I need to know where do I have to connect. So first thing I have to do is I have to actually find out which IP address the system has. So for that, I quickly go to the machine and see this is the Liberator, the machine that we just created now. And I'm going here, I'm going to find out what IP address it is using currently, network interface. Might take a second to get all the information. There we go. It says operating system is Linux. So network interfaces. The IP address is 10.102.1.4. Okay, so let's try this out, see if it works. 1.4, and we connect to the UI. Let's see. Okay, so we log in here. Seems very promising to me. System says it's healthy, so we have now created, fully automated, using solution templates in Azure, a software-defined mainframe system, which we can use. Should be ready to use. It says healthy. Let's look around, see if it actually is functioning or not. So I'm just going to see if the components are operational. So let's see. I see I have some predefined batch jobs here. I'm going to click and spool. So I can see here, okay, this is running. So let's maybe look at the dataset facility. Might take a while just querying the catalog. See all the datasets are there. The datasets that are currently in the system are default datasets that are already in. Later on, we will also see the datasets that we actually restored. Those are the same ones, the same format. This is unchanged data. So what I would like to show you is, because we have an online application here, it's an online transaction, online DB2 transaction that we're gonna move. So People of you that are familiar with mainframes know that if you want to run Kik's workload, you need to have a region. LzOnline has also an LzOnline region, so I'm going to show you these definitions just to show you what's already there, and after the reload, what will be there. So, I see here the groups that are currently attached is one group, which is a default group, and when I, for example, click on database connections, I see right now there is no connection defined. Currently, no database even exists yet. What I'm going to do now is I'm going to upload the package that we unloaded, and I have here on my notebook, to this machine. Okay, was it 102.1.4, huh? Okay. So, 1.4, huh? All right, we connect here. Type in password. Now I'm connected to the system. So I have the file here. So actually the package contains of two. Let me see. Alt-GR. I'll have to copy both. One is the description of the package. You can see it like a box. Each box has a manifest specifying what's in the box. It's basically the same principle. So now I have uploaded this package, right? It should be on the system. So I'm going to maneuver back to the UI. All right. So let's quickly see. I maneuver under administration. Okay. And I have here an option called data import. And as we can see, this is the package that I just uploaded now. This contains the application that I'm going to reload. As we can see, the state is new. I'm going to generate the reload script. What's happened now, and this is the counterpart, the counter software part that we saw on the mainframe, which was the packaging. In this case, what happens is the manifest is being read, and the package is being analyzed, and a procedure is being generated to reload all the assets containing. So everything, we have, data sets, databases, tables, load library, Kik's resources. This stuff will all get reloaded into the system, fully automatic. So I can execute this. As we can see here, this is a script, right? It does like a lot of stuff. It's called centerpiece. So I'm going to execute the script, and now the reload process has been initiated. This might take a few seconds because it's now restoring all the data sets, reloading, it's creating the database first, creating catalog, creating tables, reloading the data, updating the LzOnline resources, things like that. Okay, script has been executed. Also, what we can see on the bottom of the screen here is we can see the output of each step, what it does. We can see, okay, for all the resources. What I'm going to do is I'm going to move to the bottom because I want to see that it actually successfully complete. I can see, okay, complete, migration has been finished. So, okay. All right, I can also maneuver here in this window. So I can see a bit more what's actually going to happen. So now I need to do, in order to run this application, I need to do three things. If you're a mainframe engineer or have experience with mainframe engineering, you would notice. For the others, I'm going to explain it. So we have now all the resources in the system. They are all restored. But now we have to hook them up. We have to connect them and start the application environment inside. This is what I'm going to do. So the first thing I will do is I will attach the load library, attach the resources that we reloaded, and then I will start our LzOnline region plus our connector. So the first thing I need to do is I need to get the load library out of here. See, Control F, I think. There's the load, I think, was the name. Yeah, there we go. So this is the load library. So I'm going to copy this. Close again. So I'm going to LZ batch. LzOnline is started using batch job, also like very similar to how it is done on the mainframe. equivalent would maybe be a starter task. So I have here my JCL, and I'm going to add this like old school style. Writing JCL, maybe I can still do it. Okay, so I'm going to add, just make sure I did everything right, you know. Otherwise I'll get JCL error. For people that know, okay. So I'm maneuvering back to LZ Online. Now I've prepared my startup procedure with my restored load library, which contains all the programs required for this application. So now I'm going back to the resources, and if you remember from before, there was one group. Now there are two groups. There's one more now called IC08, which is also the application name that we are going to migrate. Okay, going down to database connections, and we see there is one database connection defined. So that means when I start the system up, when I start the region up, it will connect to the database. Okay, so now I'm going to hook up these definitions here to the region that was already there. Click, click, select, yes, save. So now the resources are connected. I'm going to start the environment. So I'm going to start this here. This is the region. Okay, I'm going to start the solicitor. We call it solicitor, is actually the connector, because I'm using the TN3270 protocol. I need something to connect to. It's basically like a network person in between, you can, you know. So I'm going to execute this as well. So now I can actually follow up the startup sequence of LZ Online. I see it's running. I'm going to click on it. It says running. And I can follow here. I'm maneuvering through Spool. This is the data sets that get created in real time in Spool that I can maneuver. I'm going here to the job log, and here it should display me the actual output or not. There we go. Okay, so there's a lot of stuff here. It says, okay, blah, blah, blah. It's doing its very sophisticated startup procedure. And what we can see here, if we look closely, we can see opening RDB connection to this database. So we have an established database connection now, and it says the region is up. It's good, so we're good to go. So now, let's see time, how we are on time. Still good, I guess, okay. So I'm going to try to connect to this region now and execute this application that we have now just live restored. For this, let me see the IP address, 1.4, yeah. I have a TN3270 client where I'm going to connect now to this region onto the system that we just deployed. So, there's a 10.102.1.4, huh? Connect 10.102. 1.4. The port semicolon is 90908080. So now I'm connected to LZ Online, well, to the solicitor technically, and I'm going to connect to LZ Online now. And if you see a blank screen, amazingly it means everything is okay. I know it's not straightforward, but believe me it is. Okay, so let's give it a go. IC08. Remember that? That is the same assembler map that you just saw in the video. So now we can fiddle around with this application. We select a country. Usually I select New Zealand. I don't know why. So what I've done now doesn't look like much, but we have executed a database query of data that has been reloaded from DB2 into LZ Relational. So I can also fiddle around with this. So I'm going to insert a new one. So let's see, keypad, PF4. Now I select insert. I do 0 and I do like
ZL test, test, test.
Okay, so now I have inserted the record into the database structure here. And when I execute this, the program that's being executed is a binary intact load module here. It's from the load library that I just attached. This is unchanged. It's executing the binary compatible code here. So I can also delete this. So let's delete. First select, okay, yes. Okay, then first we select, I guess. And then we delete. Test is deleted. And we can select again. Or let's maybe start over. So now I've deleted records. It supports all the everything that DB2 also supports. You can, roll back, unit of work, prepare, whatever. So it supports all that. If I select now, ZL says doesn't exist anymore because I deleted it, right? If I want to create something, for example, I want to insert something that already exists. So I'm going to insert NZ, right? And say blah, 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 blah. Okay, it says it can't insert because it gets an error code, right? So error condition handling is the same. So now, let's see, how are we on time? I started like 10 past, half an hour. So within half an hour, I have reloaded a binary intact Kix DB2 application with its data onto a system that half an hour ago did not yet exist into Azure. Believe me, if you would have asked me 2 years if this would have been possible today, running a mainframe application on Linux in the Microsoft cloud, I would have said, maybe not. But here we are, and it works, and it's awesome.